Hello and welcome. It is time once again to try to fix something, and today on the workbench, something a little bit different. I have a PS5 power supply here that was sent in by a viewer of my channel. His name is Marvin, and he's asked me to take a look at it. Now, he bought a PS5. Apparently there was a no power PS5, and when he got it home, found out that it was a dead power supply, likely due to insects. I think he did mention that there were signs of some bug activity. So we're going to be taking a look at this and trying to get it going for Marvin. Now this is an ADP-400FR, which is the latest revision of the PS5 power supplies. I have not seen one of these. I think actually I have worked on a PS5 that had one in it, but did not have a power supply problem, so I never messed with it. But these are kind of hard to come by at this point in time. You know, if you get looking on eBay, there's just, if you search for ADP-400, the only thing that comes up is some people offering repair services for it. So yeah, these are hard to come by, my understanding. They're a little different shape. Now I'm sure they act the same as the ADP-400, was it DR? Yeah, DR-400ER. This is the 400FR. I'm sure, I mean, they're all, going to be 12-volt supplies operating at a really high current limit. He included a message here of what he had done, what he had noticed. He noticed that the main controller IC in here, the DAP-53, he thought it had shorts around it. He measured with the multimeter and found shorts. He's included that, the old chip. And ZD37, which I think is an 8.2 volt Zener, but I'll have to check. At least it has been in previous revisions. I don't expect this thing to be greatly different from the other ones, the 400DR and ER. They don't usually reinvent the wheel. They just needed to reshape this one to fit in the new packaging they were doing for the, I guess, the new shape of the motherboard in the PS5s, the latest revisions, which I think is a what is it? It's maybe the 1215 model of the PS5. Haven't seen. They're pretty new. I haven't seen too many of them at this point. But so yeah, looks like all he really did was he noticed this Zener diode ZD37 had exploded, and thought he had shorts around the DAP-53 IC. So let's get into this thing. Now he did not tape it back together. Well, I appreciate that, because these things are a pain to get back together, or to get apart, I should say. See if we can get this tape off of here. And let's see what we find. Hopefully not too much death and destruction. Actually, this will be the first one of these to open up. Let me look. Yep. If you can see that model number, 400FR. I do appreciate, Marvin, that you did not snap it back together. It's gotten snapped in one spot there. As soon as I find my pry tools, which I just put up, I was cleaning off my workbench in preparation for this, and I put everything up. All right. Let me put these lids to the side. Although he did mention seeing a scorch mark in one of these. Yeah, there is a little bit of a scorch mark. Not sure how all that shows up. Right in there. Right in the middle. Is that where ZD37 resides? Not sure. Well, I see the DAP-53, which apparently he pulled these parts that he's added. I see a a MOSFET that has busted open over here, Q34. We'll get the microscope out, but if you can look right here, Q34 has split wide open, looks like. Let's see if we can get the microscope cranked up. Maybe get a little better view of what's going on here. Yeah, Q34 is no longer with us. Let me get this microscope turned right. Now I'm trying to remember from the other supplies I've worked on, the other 400s, if Q34 is one of the ones I've had to replace before. Okay. Yeah, it's going to be. I can see a 7 on it right there. I'm pretty sure what this is a 2N7002. Don't quote me on that. Let me look at my parts bins. Yeah, I think it was marked 704 2N7002 KT. So it's 2N7002 MOSFET that also has like some added protection diodes in there or something. Maybe we'll pull up a data sheet at some point. But I'm pretty sure that's what that was. And I think there's going to be about 3 of them that I think, I need to look at some notes, I think are all involved with the shutdown of the power supply. And I haven't understood fully what all they're doing, but just by looking at where they are in the circuit, I think they're related to shutdown. And several of them, or at least that one, I think are tied. You know, they're connected very close to the AC input line. So if there's any kind of a surge, they go first. What did we say that was? Q34. Oh, I think they've renumbered them. I think they have renumbered them. No, I found it. Yeah, Q34. Yeah, that's going to be one of the ones, I think, related to shutting down the supply under certain circumstances. So that needs to go. We'll put one that doesn't have a hole in the top of it. Is that in focus? That's a little bit better. Let's keep looking around the board here. Where is that ZD37? I see flux in this area. A couple of Zeners there we probably need to take a look at right in here. Or at least I think, yeah, no, they're both Zeners, I believe. Oh, that's ZD37. Okay. Which I'm guessing he took off. He said he took it off a what did he say? A PS4. No, he took it off another PS5 supply, didn't he? Yeah, an ADP-400FR. Let's just get the meter out and start checking some of these diodes around here. I am in diode mode. That's the one he changed out. It's not shorted. About over here. I'm trying to make sure I keep all these in the shot. That one reads. Right now I'm basically just looking for shorts. This was supposedly pulled from a working supply. ZD38 is not shorted. 36 is not shorted. I'm pretty sure that is shorted. Or maybe it's open. Does not read shorted. Or opto oscillators, a DNP-014. Where are those other MOSFETs? There should be like 3 of these, I want to say. The same number. It'd be a 704 on top. Let's see where those other ones are. Like there's been something going on here, a little splatter. Temperature sensor, negative temperature coefficient resistor. Did I overlook those other MOSFETs? That's a transistor. That ZEW is just a regular bipolar transistor. Another Zener diode, K5. It's not shorted. Okay. I'm just used to there being like 3 of those. They could have changed it. That's going to be part of a drive circuit. Drive, yeah, to the gate of this MOSFET right over here. I have not tried to apply power to it, obviously, because I wanted to see what might be shorted, what might not be. So I don't know if it tries to run and shuts down. That was good, or at least it's not shorted. Do have a few opto isolators here. See if we can check the LED side of those. That measures about 1 volt. 1 volt. 1 volt. That sounds good. So we believe this was not lightning. At least Marvin said he thought it was roach related. So, I mean, they could have stepped anywhere. He did indicate they had shorts around that ADP-400FR, which I may check again. Where is a good ground? There we go, wherever these large filter caps are. I'm going to get right over here, just totally out of focus. And let's just go across this ADP-400. With my neck, the red probe is on ground. 1.49, 0.65, 0.66. That's, I think that may be ground. 0.648, 708, 714. This one does not look to be soldered. Maybe it is. None of this, nothing short of the ground except for the ground pin. Yeah, just looking at that one pin, which may be soldered, it doesn't really look like it's soldered. That nothing on the end. I think it's making contact. Yeah, we'll definitely touch that up though. So a good starting point might be just to touch up those legs on that ADP-400 and replace this MOSFET here, Q34. And maybe give it a try and see if it's, tries to start and shuts down, or what it does. If it does, maybe it doesn't try to start at all. Alright, well, I'm still looking over this board, and I may have found another problem here. I need to confirm it. If you look right here, there's been a little repair made. I'm assuming Marvin did this. See the little bit of coating there, solder mask that's been deposited. If we zoom in though, it looks like this has been physically damaged in some way. See how it looks like that trace is broken under there though. Maybe not though. Let me zoom back out. Let's just go ahead and confirm it though. I'm just going to scratch right here just beyond it. I'm going to discharge the capacitor. Ouch. Yeah, that's why you discharge capacitors. Okay, maybe now we should discharge some capacitors. Better late than never. Which is also why I'm thinking that trace may be open. That should have discharged. Keep in mind that this was shipped to me like a couple of days ago, and those capacitors still have a charge on them. So yeah. Oh yeah, it started off like 70, 80 volts. Those are some high quality capacitors. Fun, fun, fun. All right, now we're discharged. Now let's take a look at that trace. Okay, now where were we? Where was that trace? Right there. Try this again. Okay. I'm in continuity mode. Do we have a connection between here and here? We do not. Is that even in the shot? No, of course not. Why would it be? This point in here. We have no connectivity. So that's a problem. Let's go ahead and fix that up. Yeah. I really just need to go ahead and run that straight over to that pad, don't I? Yep. Let me find some wire or a resistor lead or something. It's pretty small. Let's try, what about this right here? Probably go a little further out, I guess. we are. Trying to get as much of this flux out as I can, because I'm going to, put a solder mask on there, and that flux just gets in the way of it sticking properly. Yeah, I'm gonna need something more to put that stuff on with. Toothpick does pretty good when you want a larger amount. There we are. Okay, now pardon me while I put some UV light on it. This thing does automatically cut off. I'm just not sure how long it takes. Like 20 seconds. Maybe it's 30. Okay. Now let's take a look at it again. Maybe a little bit of heat. I'll turn this down to like 330 or something. I'm not trying to cook the board. Just want to help that stuff heat up a little bit, or help it cure. Maybe I'll hit it with some more light. You should see that sheen come off of it, and we'll have a more of a matte finish. All right. That is done. That, I think, may have connected to our MOSFET that was blown up. If we go here, under this resistor, it gets a little hard to tell here. Maybe going up and over this way. 0 ohm jumper. And there's that MOSFET. Well, let's just see. We have continuity mode. Let's just check to see if that's where it goes. So we're going from right here to, we think, up here. Yep, right there. Focus. Right here, which is connecting to one of the elements of this MOSFET, which had the top blowed off of it. So this all could be interrelated. I think we're ready to test this thing out though and see if we've done any good whatsoever. Here's that MOSFET that I changed out, the 2N7002K. You can see it's basically just a standard 2N7002, but it does have some electrostatic discharge diodes between the gate and the source. But otherwise, it's just a 2N7002. But and here is what I am using to replace it with. Straight from Mauser, if you can see that part number. So yeah, let's give this thing a try. All right, we are ready to test. I believe I've got my load connected. My variable AC supply is connected. It is turned on, but it is turned all the way down. The voltage is completely down on it. So I'm going to try to ease it up slowly and see what happens. And it's not uncommon for these things to kind of, you know, start up in a sporadic way because they tend to load down my AC supply. And anyway, it happens. I'm used to it. It's just the PS5 supplies. The 4s don't seem to do that. So we're going to start bringing this up slowly. And hopefully we're going to see some voltage come up on this. Nope. At 120. And I never saw it even try to start and run. Yeah, I'm cranked up plenty of AC voltage there. But I never even heard the transformer, you know, my variable supply get loaded at all, like something was drawing current. I don't think it ever even tried. So, let's see what we're missing. Well, it's the next day. I'm just not getting a chance to get back to this power supply. But I think I may have found a problem. Looking at this ADP-400FR, which I believe was pulled from a working another PS5 supply, like the 400DR or something like that. And I have some notes on a 400DR, like what the diode reading should be around this ADP-400FR. And if I can show you, let's see. This is, what is this? 16. We get pretty good diode readings all the way around here. There's 14, 13, 12 is not connected, 11, 10. You get these high readings. That's normal. 9, you get that high rating. This is, and then 8's like a 1.5 or something. Yeah, that's normal. 7's not connected. 6, 5, 4 is ground. 3, 2, and 2 we get nothing. No reading, and there should be a reading there. And 1 looks pretty normal. So I think our issue is going to be here. Pin 2, something seems to have broken loose inside this chip. Because I checked on a new chip, and if I take a diode reading between 4, which is ground, and 2, I get a reading just with the chip itself. So it's not like that diode reading that I have notes on is some parallel circuit connected to pin 2. There should be a diode reading right there, regardless, and there is not. So, yep, I don't think that's a good chip. Let me get this changed out, and let's see if we make any progress. Well, our ADP-53 has been changed out. I don't see any other obvious problems. I think we are ready to give this another try. AC power is connected here. It is switched off at the moment. I got my load set on 5 amps. It's turned on. So let me see if I can reach my AC power supply here. It's going to turn the voltage down. All right, AC voltage is on. I've got it turned all the way down. I'm going to ease up the AC voltage coming in. See what happens. Nothing. Not a thing. 120 volts AC in, and it's not doing anything. That's not progress. All right, I wanted to point out something. I think maybe I overlooked something when I tested it earlier. I was just checking for the supply voltage into this IC, and it's there, about 18 volts. So it should be, in theory, it should be running. I can show you that just for the heck of it. Pin 18. Let's see, it's on this diode capacitor combination right down here. Not pin 13 into the IC. 18.48 volts. So that's there. It acts like, I mean, the chip has power, so in theory she should be running. But she's not. Let me turn off the AC voltage in. I'm switching it over here on my isolated supply, and watch the load here. Watch the current and the voltage. See it? It tries to run. It's coming up and shutting down very quickly. So we've made a change. She's trying to run. I don't think it was trying to run at all in the beginning. So now we have a shutdown problem, a fast shutdown problem, which is probably going to be fun to find, but still, at least now I know it's trying to run, and for whatever reason deciding it needs to shut down. So that's what we're chasing now, a quick shutdown issue. All right, I may have found another problem here I wanted to share with you. If you remember Q34 here, I changed it out early on. The plastic case was cracked, and it looked like it was done for. So I changed it out. But now, this is the gate, this is the source, this is the drain of this MOSFET. And if I measure between the gate and the drain, 2.7 ohms. No matter which way I turn my leads either. So it looks like it has gone bad. I'm wondering if the bad ADP-53 blew it. I don't know. Let's lift one of those legs and let's just see if the short is something in parallel with it, or if it's the IC itself. But I got a feeling it's the IC itself. The MOSFET, I should say. I'll lift this drain, since it's over there by itself like that. We can just easily do that. Isolate it. Now what do we measure between the gate and this drain? 3 ohms. So if I go to the pad down here, yeah, we're in the K ohms. But yeah, this thing seems to have gone bad. So let's get that changed out and see what happens. All right, well, I've changed out Q34, that tiny little MOSFET. I've changed it out once again. Let's see if we've done any good whatsoever. Oops. If I can just reach over to my power supply and flip it on. No. Denied. All right, I am still chasing the problems on this PS5 supply, and I'm going to go back and look at something I worked on earlier. Like when we changed out this MOSFET right here, and it still seems to be fine. After changing out the second time, it's not shorted, so I think we're good there. But that also connects with these resistors over here. These resistors are connected to your main bulk filter capacitors, which are running like 160 volts or something right now in standby mode, you might say, or when it's not running, it's like 170 volts. When the power factor corrector kicks in, I'm sure it's like 400. But anyway, there are two 7.5 megohm resistors right here in series, and then they connect. They go into pin 2. There's also 100K to ground right over here. And this, I guess it's right. This Zener is the one that the owner changed out, 8.2 volt Zener, to limit that voltage. And I'm not sure if these resistors are good or not, particularly this one right here, which is the one I had to reconnect that trace to. So let's look at it under the microscope together. And if you look at it, you can see where I reconnected that trace to it. We'll zoom into the end of it there. See how it looks a little bit burnt right there on the end? So I'm not sure if this is still good resistors. And they're hard to check in circuit because there's such a high resistance. You get strange readings, with any kind of parallel resistance going on. 7.5 megs is hard to read on the board. So I think what I'm going to do is lift this upper resistor, and these are in series. So if I break the series chain, I should be able to check them no problem. Then I could do this one, but I've got all this work done here with this trace. I'd rather not mess with that unless I have to. But yeah, I think I'm going to lift this one, and then we'll be able to check both of them and see if they're still good. All right, well, I've lifted that one resistor, breaking the series chain. Let's see what we get. 7.5 megohms. 7.48, that's pretty good. What about this one? 7.5. They're looking pretty good. Okay, what about this? Also connects to 100K down here. If we follow this around, splits under here, and part of it goes down to that MOSFET down this way. The other half, here's the Zener that Marvin changed out, 8.2 volt Zener, and here's a 100K ohm resistor to ground, measuring 82K ohms. Check it this way, 83K ohms. Of course, we are still connected to the IC down here, so oh, that's the wrong resistor, isn't it? That's a 1K ohm. Yeah, never mind. 820 ohms. I'm looking at the meter at an angle. Where's that 100K? Oh, down here. Right here. 50K ohms. 50K ohms. We are still connected, we are connected into the IC right here, so it's going to be hard to get a measure on that one also, but it's not high. Well, it does appear that our resistors are just fine. Those two 7.5 megohms. Now I've kind of tried to draw this out to show what I'm doing a little bit better. This is the divider chain for the boost sense signal going into that ADP-400 on pin 2. So basically this would normally be about 400 volts if the PFC circuit is running, which ours is not, so it's running about 160. But that gets divided down, and this is the Zener that apparently was blown up that the owner replaced, 8.2 volt Zener, to limit how much can go in here. And it does look like this is the little MOSFET that I changed, Q34, and it looks like what this is a shutdown circuit from what I've been able to see. Basically, this is how the ADP-400 tells what the power factor corrector is producing and adjusts accordingly, according to what kind of feedback it gets. And if you pull that feedback to ground, it's a shutdown signal. It tells us saying it's time to stop and just shut down. And I think that's what's happening for whatever reason. I'm not sure why, but that's what's happening. I believe it's being held down. So what I'm going to do, I think, is lift the drain of this MOSFET and thereby disabling that shutdown signal. And if that works, then we'll figure out why it's being triggered to shut down, because it's driven by an opto isolator here, which the other side is coming from this I think it's a ADP-400, which is I've never heard of before and can't find any information on it. See, can we see the number on it? Yep, ADP-400. That's coming from the opto oscillator in question would be, you know, this one. If I can show you right here, that's the one it's a signal driven from here off of, I can't remember, pin 1 or 2, that turns this on and ends up coming over here and driving our little MOSFET Q34, which then shorts the sense voltage right there to ground. So I'm going to lift that and let's just see if it makes any difference, if she'll stay running. Well, the drain of MOSFET Q34 has been lifted. Let's see if this supply will run now. I've got my load on. Get my AC voltage switched on. See what happens. She's trying to come up, but she's cycling. I didn't see it output any voltage, but it was loading down my supply over there, my AC supply. Let's see. Yeah, I'll show you what it's doing over on my AC supply. Trying to come up, but not quite doing it. After I shut it down, I made a few quick measurements, and the voltage across our main filter caps down here went over 500 volts. So our power factor corrector is just running wild, and that's what's going on. So yeah, I've got to figure out why our voltage is running so high. But yeah, it's just kind of running away with itself. So I've discharged those capacitors so they would not get damaged, hopefully, and got to figure out why we're not properly keeping that voltage to around 400 volts. All right, where are we now on this PS5 supply? Well, I have been checking pretty much everything I could on this feedback circuit. We've checked the resistors. We've checked this resistor. Well, I lifted it so I could check it. I don't have there's a capacitor here to ground, which measured 560 picofarad. It seemed fine. However, this diode, this 8.2 volt diode that Marvin had changed out, and I thought it was good because I got a diode reading across it in one direction, 6/10 of a volt, but I was probably reading into the ADP-53 pin 2 on that same leg, because this thing measures 117 k ohms with my ohm meter in either direction. So it is basically breaking down and leaking. And I don't have one this size. I've got others, other values that are in the same package, but I don't have an 8.2. So what I have done is substitute in a full size, half watt, whatever it is, 8.2 volt Zener. Good enough for testing. Kind of standing. It's kind of, I had to get another ground point, further away, but whatever. Should work fine for testing. And also, I believe this opto isolator is bad, because I was testing and there's 18 volts here and I'd get like 17 here, and there was no voltage turning it on over here, so it should not have been conducting, but it was leaking. So I've got that lifted right now because the MOSFET is reconnected, and I've lifted it here because it was, I think this is fine, it was just kept getting turned on, and I finally figured out why it kept getting turned on. It was this I think this is broken down. You notice all these things that are damaged are on this same circuit. This was damaged. This was popped open. This Zener, I think, we had blowed up. Let me get it where you can see better. Let's see. This is damaged. So they're all on the same circuit, which is a high voltage circuit. It probably runs at 400 volts or so normally when it's working. So anyway, that's where it's going to be where a cockroach stepped in there and caused all this mayhem. All right, I've got my oversized Zener diode, 8.2 volt in there. That this opto isolator, if you can see, is still lifted right there. You can see that top leg up there is lifted to disable that shutdown circuit. We'll have to find one of those, I believe. I don't think I have that. That's a 1004. I've got a lot of opto isolators. I don't think I have that one. And I am measuring my voltage across that capacitor there, just in case it goes sky high. I have not discharged it. I should have done that. But in case it goes sky high, we'll know it, and maybe we can shut it off in time. So let's see. My load is turned on over here. Let's see what happens. Hey, we're running. 11.8 volts, 5 amps of current, and 397 volts generated by the boost of the PFC circuit. All right, we're working. I think we're almost there. But we're going to have to source some parts. Like I said, that 8.2 volt Zener, the proper one, and that 1004 opto isolator. Other than that, I think we will be good. So let's see if I can come up with some parts. And just like that, our parts are in through the magic of editing. But there's our part numbers that I'll be using to finish up this repair. But I think that's all we need to get this thing fully restored. So let's get with it. All right, those components are changed out. Before we test this, I'd like to show you, this is the opto isolator that I removed. If we go across the pins 3 and 4, which is the collector and emitter, I'm in resistance mode. If I can get across it, 2 ohms. So that collector emitter junction of that photo transistor has broken down. So that's why our protection was being triggered all the time, our shutdown. And this is the that 8.2 volt Zener that I replaced. If I can get across it. 120 ohms. And I believe it reads that no matter which way I turn it. I'll flip it around here. It's probably going to go flying here in a minute. I'm going to lose it forever. I should have used my smart tweezers, but I'm not that smart, I guess. Anyway, it's 120 ohms. So, yeah. And that's why my PFC boost voltage was going so high. That thing was acting as an added resistor to ground, which would mess up the whole divider trail and the divider chain, I should say, and that's what skewed the voltage to go so high. That circuit was doing all it could to satisfy its feedback loop, and it couldn't quite do it. Let's try this thing out now. All right, let's give it a quick test before we put it back in that housing, because that housing is a pain to get open back up. Let's give it some AC voltage. There we go. Working just fine and starting reliably. I kill the voltage to it, bring it back up, starts up every time. Well, let's get it back in the housing, and I'll probably let it run that way in the housing for a while just to give it a good test. And here we are, fully reassembled and still working just great, outputting the appropriate voltage. And I did want to show you, just for comparison, I thought that this supply was a different shape than the older ones. It's not. Here's a 400DR. It's the exact same shape, but they moved the 12-volt terminal output location. Like, this is a 400DR. You can see where the output terminals are compared to the 400FR. I thought it was a different housing shape, but no, same housing shape. They just, I don't know why they had to do that. You know, it would have been better for for all of us if the power supplies had been universal. You could have swapped them around as needed, but they decided to change it. Well, I hope you enjoyed that one. And Marvin, I'll get your supply back in the mail to you today, and hopefully that'll get your PS5 going. Well, hope everybody out there enjoyed this one. If you did, please give me a thumbs up, and I will see you in the very next repair. So long for now.